All right. Thanks everybody for coming out.
You're welcome.
Thank you.
Sorry, that's how this is going to go.
All right. My name is Nathan Bates. I'm it's monitoring critical infrastructure traffic on fresh networks. That title was completely made full of buzz terms just so it'd get accepted to another conference that I spoke at. It worked, and then they expected something kind of different, but by the time I got there, but that's okay. Yes.
Is that like Fresh Networks as in like Fresh Prince of Bel-Air?
It's a lot like that.
Okay.
It was supposed to be, it's a term that we brainstormed within our group on to mean like newer networks that you haven't really looked at before. Things that, new traffic, new data, people that, you don't understand the data set. You're trying to discover what's there and what you can do with
We
it.
thought you meant like dope.
It's pretty fresh. It's pretty dope. That's part 2, monitoring critical infrastructure on dope networks. What was that?
Reservoir.
That's right. So the agenda, talk a little bit about myself, not very much, but why we do it, why not, what it's going to buy you in your infrastructure. Has anybody here used Bro before? Anybody? Lonnie has.
Yes, sorry.
That's good. Neil has. Is anybody doing?
You about Bro before? Does that count?
I think it counts. I'm a pretty huge fan of it. Does anybody doing current network monitoring for their businesses?
I use Snort.
You're using Snort, so you're doing just more traditional signature-based IDS.
Mm-hmm.
Cool. So we got Snort. Anything else? Suricata. So same things, similar signature-based. We love Suricata too. It's awesome. It does a really good job. Anyway, so we'll go through some of the definitions, the different methodologies of how we're doing it, the type of hardware, the type of software that we're using, how we're looking at the data and how other people can do it too, how we're bringing it in with threat data, and then we'll just kind of move them for questions. If you have comments or questions or want me to slow down or be more specific, yell it out. This was written at a little bit of a high level. There's a little more where it'll get into details. So if there's something specific that you want to know, let me know. I updated the slides a bit. It was written about 8 or 9 months ago, but everything's still current. So I'm from Salt Lake. We're talking about Adobe. I'm a security guy with Adobe. I'm on the digital marketing security engineering team where we build out infrastructure on our product environments. So the product environments includes all of the digital marketing side. It's pretty big all around the world, lots of stuff going on, lots of bandwidth. That means that we had to come up with ways to look at the traffic, all egress traffic, southwest, north, south, east, west traffic, and figure out what we can do with it to understand what's going on. We have a really good team that's there, and we have a lot of people who do put energy into these projects and what we do with the data, and a lot of that is kind of what makes it great. I do like Utah security groups, DC801, 801 Labs, even though I haven't been out much lately at all, sorry, and 3D printing stuff with my kiddos. So Bro is it's network data. It gets broken out into session-based data for everything that's going through is kind of a new line. So a TCP request happens, it does a handshake, it acknowledges, it sends data across, and it tears it down. That all gets put into one log in a primary, a Conn log. And then for every protocol that there's dissectors on it, it breaks those out also, and really separates the information, puts them into separate fields. You can write to common normal logging, or you can write to JSON. You can write to a lot of different formats depending on how you want to ingest it. If you're ingesting it into big systems like Splunk or Elk or something like that, it's usually more useful to put it in JSON formatting because you're going to have a lot of problems with field breaking and just bleeding over because of the type of data you're bringing in. So if you're getting into big data with lots of systems, I would just start writing to JSON and work around there from the beginning. With the type of threat intel we're talking about, we buy a lot of intel. We pay people way too much money for crap that most of it's junk. I don't think there's very many super good threat intel companies that it's worth. All of our good intel, it comes from our internal sources, our internal IR, internal forensics. So anything that goes from those into crits, we pull that directly in, and we still search for all of that directly with Bro and all of our other sources that we're using too. It ends up being way more useful. But MD5s on files, you can do inline MD5 check something on all files that are transferred, and you can do comparisons really easy using Bro and some of the different sources with that data. Same thing with emails. If you actually are, looking at that, depending on what's going on, it's easy to do with it, and dump to systems where you can have people respond to that appropriately. Fresh networks, like I said, it's kind of a buzz term. A lot of people don't know what is happening on their networks pretty much at all. They haven't looked at the data. They don't know what's normal. They don't know if their developers are all following specific RFCs, or if connecting on 443 going outbound to AWS, not using SSL is completely normal, right? And a lot of groups it probably is, even though it's a terrible, terrible practice. So once people start looking at that and understanding what's supposed to be there, then they can know what to start looking for. We talked a little about the sessions already. Some of the main terms, tapping any of these things, anyone using IDS is already going to understand a lot about taps, just network taps, physical boxes that you plug the cords through, they can go through, you collect data off of there, or spam ports. Just you configure the ports on the switches to send all the data. There's port aggregators, or things like AppCons or Gigamons or things like that, to where they look like big switches. You configure all of that data coming from ports or span specifically to bring it out. So if you're building anything for multiple racks of systems, I mean, you're going to be pulling port aggregators and everything else in. There's just not other good ways to do it. We avoid spam ports like the plague. Anytime switches get busy, the first thing they quit doing is sending everything to our spam ports. That means you're trying to put sessions back together with RSA or with IDS or with Bro, and you have half the stupid packet. Which makes it really hard. So if you're in a small location, you single servers, you can use spam ports between 1 and 100 servers. Really, it's one physical core to about 250 megs of traffic is what's worked out for us. We can get 2 to 3 gigs out of most of our boxes that we're building, and then we have some locations that we load balance those in a few different ways, usually directly off the port aggregators, to where we'll have 6 to 8 to 10 boxes in those specific locations, and we're breaking all that data out. It works good. You are going to get some loss as far as on the capturing directly with the interface, or at the AppCon, or at the driver layer. There's lots of places you can lose data. Medium locations, and this all obviously goes back to the amount of traffic, and really even the type of traffic you have. If you have very, very dirty traffic that's all over the place, you're going to have a harder time getting it all figured out. But overall, this is a lot of kind of the industry suggestions. So people do start using taps as things get bigger. They'll put in small clusters. They may do it with a server master cluster directly with Bro. And then with large boxes, like I said, you have almost everybody that I've seen with large enterprise environments or large data center environments. Lots of port ags, tap spans, lots and lots of hosts, lots of data. So I'm going to cruise through a lot of this. The gist of it is with the small boxes, it really is commodity hardware. Whatever you have sitting around for these smaller environments, if you have just an office full of people, a couple servers, and you're just trying to understand what's going on, you don't need to throw a lot at it. And for these smaller environments, you can get run them off of the spam ports, be collecting traffic, and you can run it with both IDS, traditional IDS like Suricata, and Bro at the same time. As you get more traffic, that doesn't work, and you have to break it all out. But for small environments, it really does. It works great. The data is going to the same place. You can use the same Splunk or Elk forwarders to get everything off and get it organized. But for POCs or small businesses, like one system is really fine. Yeah.
Why built-in networking cards?
Because it was free. Did I actually put that on there?
Yeah.
So that's none of the stuff that we did. We did nothing but Intel So, let's go back. So Intel's with the 560 SFP specifically, and Miracom's for the collections. So I think the point of that was whatever you have for a small shop is better than nothing.
Start and get a baseline.
Yeah. For medium systems, like that's when you get more into stop trying to use PF Ring and trying to use Miracom for collections. If you are using span ports, if you're getting more data out of it, we have way better luck collecting with those than just standard drivers. And same type of thing. C packets is getting really big for more of an open source type collections like Gigamon or AppCon, and the Bro project. They run a lot of different kind of workshops in different areas. And there's like BroCon and everything. It's going the same time as Black Hat, so I mean, a lot of people end up choosing Black Hat over that. But there is a pretty big community that's building around it. But like I said, they use tap spans, lots of fiber cards, Miracom cards. You have to have specific software for PF Ring and the Miracoms, but it comes along with usually with the purchase of the cards. We can talk about a little bit about the infrastructure and the flow of data, where you put things. So everybody's kind of different on this type of thing. With traditional IDS, you don't want to be listening on the outside of the firewall just because it's full of garbage. People can use that data in specific situations if they already know what's going on and they just want to understand that. They can separate the data sets to understand this is external traffic, this is what's going on. We can try and correlate with that with the logs on the other side in case something gets through. But most shops aren't to that point or don't even want to see that data. But it's the same type of thing. Understanding and gaining NAT information around load balancers can be useful when you're tapping on both sides of the firewall or the load balancer, but that's really where that's primarily happening. So taps both sides, bring it in through span ports, and dumping that into a port aggregator. From there, it kind of gets handed off to the Miracom or the PF Ring interfaces. That's usually Intel cards, and divided up per workers per load. Physical CPUs is all we really count. Anything past that doesn't work as far as trying to figure out the bandwidth or anything like that. Maybe somebody can get it tuned to work really good with like virtual or with multi-thread, but physical cores is all we ever count. So it's picked up by the managers, written out to logs. You pick that up with a forwarder, and you dump that to wherever you're going to read it, whether it's Elk or Splunk or just flat logs, whatever you want to do. PF Ring is a little finicky. A lot of people using it, the general rule is they look at whatever the current Security Onion version is running, and then that's the version they pick. You can be doing everything perfect. You'll upgrade PF Ring specifically, and everything will go to hell. We do use PF Ring a lot with like things like Siricata for the different groups that are out there too, if you're trying to do the high-speed collection. But a lot of it has, it has to be compiled different. Even things like, especially with Miracom, it has to be compiled slightly different, has a different tool sets. Even things like TCP dump on the system, you have to have like things put together a little bit different to actually work with it. So for this, we'll talk about Bro, Critical Stack, and Splunk out. Critical Stack is, do you guys know, crap, I just lost his name. He's the guy who runs Critical Stack. That's not good. I should look it up really quick, but I'm not going to. If somebody wants to look up who that is, I'd appreciate it. He's a really good guy. He's at most of the events. He does really good training. If you're at Black Hat or DEF CON or ShmooCon, he's usually there giving some type of talk about blue teaming / bro / anything else. It's been around for a long time, since '95 or so. That being said,
Liam?
Yeah, Liam Randall. There we go. So Liam he's really good. He's a smart dude, super accessible. If you have questions, like I've never had any problems with him. The Bro guys, as far as the development team, if you go on Freenode and jump into Bro, most of the primary developers are in there and just hanging out all the time. And I've never once had them not be helpful. So they're good guys. So yeah, Bro, Vern is kind of the guy working with Berkeley Labs. He started putting everything together in '95. It's really only been probably the last 5, 6 years that I've heard about it, and that I know anybody else who's using it. And even now, like I use it from on my box directly every time a PCAP's handed to me. Like the first thing I do before I even load it into Wireshark is run it through Bro, dump everything out, and review the data there before I actually go through Wireshark. And it's just because of how it breaks the data down, how just to get a quick understanding of where everything is. So it's been developed since '96. It's kind of just been going through that since then. So you can, a lot of the examples that I have as I'm going through it, you can go to try.bro.org and they have running inputs. There's different data sets that you can load through that to kind of follow along with things, and they have programs or scripts, Bro scripts that you can write for pretty much anything, any type of dissector that you can think of.
Did you say programs?
I did say programs. So the programs are pretty good stuff. That being said, I've done small things like doing things about ignoring specific subnet to set subnet traffic that's internal to where I didn't want to dump that and deal with it in it, but I haven't done a lot past that yet. So primary configuration files, that it doesn't take much to actually get it going. You define your local networks, your 172 or 10. The local bro is where you're going to define enabling or disabling any of the dissectors or any of the protocols that you actually want to deal with, especially if you're adding more on there. And node is specifically for things like how many processors you're going to be using, how you're going to have them assigned, and yeah, basically how it's going to load balance on the system. It breaks into a few different logs. I don't know if anybody's looking. The analysis ends up jumping into separate logs depending on the source. So the primary log for everything is the Conn log, and it's just the connection log. It includes the primary source, source port, destination port, TCP history, including, well, it'll walk through in a second, just how it's set up, how the connection was handled, how it was terminated, size, duration, all that type is put in there. HTTP is, of course, is normal HTTP logs, full URI, full GET, all of that's put in there. It's a little bit closer to normal, like Apache type logs, but not quite. DPD is just not dynamic protocol detection. It will look for things specifically like what we were talking about earlier. If you're running normal HTTP on HTTPS, or anything FTP running on port 80, things like that get pulled out really quick. Weird is usually things not following RFC just in general. They get extracted. There's a lot of good information that's pulled out of it, and sometimes it takes a little bit to get through it, but it's pretty useful. So this is examples of the primary Conn logs, like what I was saying. It has the time that you can convert them a lot just locally if you want, but a lot of the using Splunk or Bro, or excuse me, Elk, you'll be able to do that within the systems. The second field, and you cannot see my mouse. The second field right here is just unique identifiers per session. This carries across all of the different source files. So if one connection is made, it breaks into a Conn log, and this is the Conn log, and it's an FTP. It's going to write to another log at the same time with the FTP specific data. You can use the unique identifier to go across from multiple sides. If you're seeing weird traffic, things that do break protocols, or things that, say if it's DNS where it's, I don't know, a zone transfer where it's really, really big, right? It ends up breaking the way that's looking for. You're dumping like 200K across the zone transfer. It breaks it out, and you see lots of things that don't make sense. It's going to dump into other files, either notice or weird, with tying out directly what was the problem or what it saw as not following the RFCs, but then you can still jump back to the Conn log or the protocol log to kind of show what's going on. So source, destination, destination port protocol, and this actually does have the, these are bad examples. Yeah, let me just keep going. So I mean, you can kind of see the general gist of what's going on. It has the time and everything else. This part alone feels a bit like flow traffic. I don't know if anybody uses NetFlow anywhere. Nobody? Do you like NetFlow? Yeah, I don't like NetFlow either. So it's very useful from the network perspective when you're trying to understand what's going on, but from the security perspective where you're trying to actually understand what's in that data, to extract it, to use it with anything other than IP, with domains, with requests that were actually in there, it hasn't been enough for us. So when we get requests and we're tied back to looking at the NetFlow data, like all we can tell them is like, yeah, there it is. That's how much data went out, and that's it. It hasn't been enough for me and with much of what I've done. So with the HTTP requests, yeah, you can kind of see like what's happening in this specific location. Load balancer removed. As far as the actual URI going through, actually pulled this from like a test environment. It has the full request. It has the agent as far as what's being applied. It'll have the method, whether it's get or head or put or anything like that, and kind of the response. The exported forward data that gets assigned to that within it can be really useful for getting information past if it's being added coming through load balancers. The only other time we use that really heavily is certain DDoS precautions where you're trying to understand how things are being chained multiple times before they're sent to you. You can extract that data to highlight attacks kind of before they start. So the DPD logs, it will specifically say what's wrong with these as far as a source destination port. They're saying, okay, we're looking at this. This isn't a reply line. There's nothing in there that's tied to HTTP. So somebody else is doing something non-protocol specific on this. Weird log, same type of thing. It's used a little bit different. We end up identifying a lot of asynchronous routing with the DPD and the weird logs also, to where we get those because of bad span ports, because of bad sizing. We don't have enough size in there to be able to deal with the bandwidth, or just because of bad routing in general. We're going around a tap point, and because of that, we get one side of the traffic, which means we're only putting part of the conversation together, and it's not enough to get full data. You might see part of the request, but then it's going to look like there's no response. So you can do pretty much anything with the primary scripts, from tuning scans, stats, detecting specific trace routes, detecting through SSH tunneling to see if there's mirrored commands as far as packets going through. You see that's there, and then you see something else like coming back within a little bit. There's a few different scripts that people are using to detect the tunneling. We hash all files going through it right now, and we submit those to malware hash registry to say, okay, what's going on with this? This was sent across FTP. This is sent across HTTP. This is the file. This is the hash. This is the return, and we'll ingest that same data and then correlate it with anything else that's happening on the system. You'll get weird returns on some of the requests or hashes to where they're test information, and people will that gets flagged as being bad, but it's still good to know. Even detecting hard herd bleed, which is not very many people know about herd bleed, so that was probably a fast edit. Lots of protocol support. Like I said, the Bro Intel framework, a lot of the PF ring specifically works off of those SSH tunneling notifications. Bro file extractions and Bro phishing are like two of the scripts that I actually like, specifically to more than just getting all of the checksums out. You can actually write them and categorize them based off of the file type. So obviously this isn't something you're going to do on maybe even a lot of enterprise networks, just based off of your user agreements or where you're at. But from service provider environments, I mean, the data's there to, we're responsible for a lot of stuff, and we have to kind of deal with it. So you can extract all those files, break them up, and then do whatever analysis that you need to after also. There are the different ways to do the visualization. I'm a huge Splunk fan. I like it. It's expensive as hell though. Anybody who's trying to dump this type of data into it's going to run into problems. It's easy to get the data in. There's apps already created by Splunk on Splunk base that you can use to get them installed on the forwarders to collect the data, do all the field extraction automatically. It's super easy for visualization to understand what's going on, from what location, where it's happening, and what you want to do with it. And it's easy to plug into data models within Splunk to use with other sources. So you can make it part of the network data model, just like you can firewall traffic or PC or VPC flow data coming from AWS. Plug it into the same locations and use searches that spans all sides of it, which makes it pretty simple. But you're gonna pay for it. Elk, anybody using Elk? All right. So Elk, from my experience, and yell it out, Nemus, if you disagree. It's cheap.
Yep.
Yeah. It's easy to get data in. That was no different to me than Splunk. But when I was trying to do a lot of custom visualization, it was a pain in the ass. Trying to get it to do what I wanted to do without as much very, very applicable experience with it. It was tough. What do you think about Elk? Thoughts on it?
Yeah, there is a learning curve to it. My biggest problem is it's a CPU hog.
So how big are you able to scale it right now, or is it
Well, I
smaller
only
locations?
I have 2 locations with 10 servers,
Okay.
so it's not too bad. But a lot of times what will happen, cause I'm putting a lot of stuff through it. So I'm doing all my FIM and all my other stuff through it too.
Oh, really?
Yeah.
How are you collecting the data with it? I mean, it's not relevant.
Yeah, I'm using Audit D we built regex expressions to parse Audit D.
Cool.
And then parse it in there so we can keep track of it. The nice thing about Elk, well, like Logstash, is I can write little scripts and I can put alerting, so I can send all that alerting like directly to Slack. And
Nice.
so, we have a Slack channel, and so when someone logs into a server, I know immediately who's in what server at what time. And I have an audit log I can quickly go through, and there's other alerts and other things we've got going through there. So I kind of use that as my data pipe for pretty much everything.
So that's really the goal with it, and that's what we're trying to do too, is to use this data with other data. So we're bringing in all our primary syslog, applog, IDS, like bone scan data. Everything is going to one location along with the network data. So all the threat intel data, we're bringing it to one source. So you can do things like, say, has anybody heard of Hubble? It's an open source project coming from our groups within Adobe, to where it's host-based intrusion detection. It includes file integrity monitoring. It includes OS query support for getting the commands back from the system for things like looking at open processes connecting out, comparing checksums of memory to on disk, things like that. And we're bringing that all in and then using that with data as far as comparing it with the Bro data also, which is all the network traffic. It's pretty sweet by the time it's done, but it is a lot of traffic just to make everything work. So even things like the session history is included with that. There's some examples here just tied to Bro, because tied to Splunk, because that's what I'm better with, to where you can understand how your sessions are being put together, how they're being torn apart, which ones are having issues. So if you look at the detailed info on here, I should have like a little agenda. So I'm looking for data here that's really, so index Bro, that's where the data is going to, where I bring it in from Splunk. The source type is tied to the specific log, the Conn log, where we are getting a lot of parts out of it. The history is uppercase, lowercase. If it's lowercase, it's the responder. Uppercase is initiator. So SYN act it's just going to be the actual TCP connection with kind of what it's doing. So this one's creating it, getting an acknowledgement from the same side, and then getting data with no response from the other side. So this is just pulling out a bunch of information where it's one-sided conversations and then breaking them out by subnets and then visualizing it to understand which ones are doing what in what areas. Where we end up using that is to identify bad tap locations, bad spam port locations, bad bad routing locations, so we can put in effort to start identifying like what we need to fix. Capture loss specifically is on the worker, the Bro worker server with, you're going to be losing traffic at the actual interface, the Mircom or PF Ring or Intel card, or actually within Bro. This will track that by through, and I mean, you can break it out and kind of to understand what's going on. There are lots of sites that we have a lot of problems, and usually it's because of shitty data. Shitty data means that you can't deal with it, and you kind of just work to get the data better, like I was talking about. This is that same type of graphic. Should have updated these a little, sorry guys. It would be different parts of the conversation as far as understanding if they're the SYNAC dev, or excuse me, SYNAC data or Handshake Act data. So one of us would be just the initiator versus just the responder. So with two different sides of the conversations and which tap points and locations you're kind of associating those with. Breaking those same things out by subnets. We're going through and we're just graphing out the capture loss type information. And a lot of this is not, honestly, even the things that we use primarily. Our SOC staff uses a lot of it for everyday investigations, and we do use it every day for more of our advanced correlation searches where we're pulling the data out. And that is using it with the other data, using it with phone scan data, and using it with the host-based intrusion detection data to as that kind of secondary source. We've confirmed there's data going outbound after there's something wrong on the servers. The Bro Intel framework it will write to a separate file where you can create your own Intel. If anybody has any questions, you can reach out to me. I'm in Brutus in Freenode in the DC801 channel. Let me know. Thanks.
Perfect.